Welcome, humans, and any celestial body else out there listening. This is Curious Minds, Infinite Answers. I'm your host, Courtney Christine Koskin. This podcast, simply put, is a mix of human curiosity and how, with the help of AI technology, curious minds can get the answers we seek. Let's get mind-bending and plunge deep beneath the surface of our everyday thoughts. Let's begin. Good day to you, and welcome back to Curious Minds, Infinite Answers. I'm Courtney, your host, and today we're talking about quantum computing and the future of this technology. But before I proceed, I'd like to make a statement. I am not blind or deaf to the pain and chaos happening around us. The world often feels like it's crumbling around us. Climate change, conflicts, inequality, misinformation, these are real, pressing issues, and they can make us feel powerless or overwhelmed. But I believe that it's precisely because of these challenges that we need to remain curious, hopeful, and engaged. Instead of feeling helpless or turning away, let's choose to focus our attention on conversations that inspire solutions, ignite meaningful dialogues, and build understanding. By talking about the things that truly matter, topics that resonate, not just today, but for decades to come, we can create lasting change. Because in the midst of uncertainty, our voices matter, our choices matter, and what we choose to think about, discuss, and share has the power to shape our collective future. And that is my whole heart's intention with this podcast. Thank you. I, like many out there, are very interested in learning more about science and the quantum realm, thanks to shows like Star Talk and platforms like YouTube, where the learning really is endless. I genuinely feel that quantum computing needs to be better understood by the majority so that we can understand going into this next era of technology what the heck is going on, what our part in it is, so that we're not blindsided, taken advantage of, and ultimately so that we can continue to do what's best for humanity. So with that, let's jump in. Imagine a world where computers can solve problems in seconds that would normally take today's fastest supercomputers thousands, maybe even millions of years. A world where we can accurately simulate nature at the molecular level, revolutionizing medicine, materials science, and artificial intelligence. Well, that world is not science fiction. It's the future of quantum computing. If you've ever heard the phrase quantum computing and thought, that sounds complicated, don't worry, you're not alone. I'm no physicist, but I do love learning, especially about technology and what's to come. This one I took a deep dive into and thought it absolutely had to be shared, even if just in a nutshell in this podcast episode. Today, I want to break this down in a way that makes sense, even if you have zero background in computing or physics. And we'll get it all in under 30 minutes. Before we get into quantum computing, I want to first define what the word quantum even means. At its core, quantum simply refers to the smallest possible unit of something, usually in the world of physics. When we talk about quantum mechanics, we're talking about the science that explains how the tiniest building blocks of our universe, things like atoms and subatomic particles, behave. These tiny particles don't follow the same rules as the world we see around us. They can exist in multiple places at once, teleport information instantly, and even behave differently depending on whether we're watching them or not. It's almost like a glitch in the universe's programming. Quantum computing is what happens when we take these bizarre rules and apply them to computers, allowing them to solve problems in ways that regular computers simply can't. So when you hear the word quantum, just think of it as a way to describe a world so small and so strange, as of now, that it bends reality as we know it. So what is a quantum computer, and how does it work? Let's start with how regular computers work. The device you're using right now, your phone, laptop, or tablet, runs on what's called classical computing. That means it processes information using bits, which are tiny switches that can be in one of two states, 0 or 1. Quantum computers, on the other hand, use qubits, short for quantum bits. And here's where things get really interesting. A qubit is different from a regular bit because it doesn't have to be just a 0 or a 1. It can be both at the same time. Think of flipping a coin. Before it lands, it's technically both heads and tails at the same time. That's what superposition is like for qubits. To understand why quantum computing is such a big deal and why I really want to take a look at it today, let's talk about how we got here. In the 1800s, mechanical computers were created, like Charles Babbage's analytical engine, which used gears and levers to perform calculations. Fast forward to the 1900s, we developed electronic computers using vacuum tubes, then transistors, and eventually microchips, the tiny circuits that power our phones and laptops today. But here's the problem. As we keep making computers smaller and more powerful, we're running into limits. This is where quantum computing comes in. In the 1980s, physicist Richard Feynman proposed that if we want to truly simulate nature and solve complex problems, we need computers that work like nature does. And since the universe operates on quantum mechanics, so should our computers. That idea led to the birth of quantum computing. Okay, so what does a quantum computer look like? You might be picturing some kind of high-tech, glowing supercomputer. But in reality, quantum computers look even weirder. Most quantum computers today are built by companies like IBM, Google, and startups like Rigetti Computing. And they look less like a laptop and more like a golden chandelier hanging inside a giant refrigerator. Why? Because qubits are super delicate. They need to be kept at incredibly low temperatures, close to absolute zero, which is negative 459 degrees Fahrenheit, if you were wondering. And that's colder than outer space. The reason for this extreme cooling is that heat and noise can easily mess up quantum calculations. Quantum computing isn't just about cool science, pun intended. It's also about global competition. Right now, countries like the United States, China, and the European Union are investing billions of dollars into quantum research. And that's because quantum computing has the potential to break encryption, which means it could crack even the most secure passwords and government codes. That's a huge deal for national security. China, for example, has already made breakthroughs in quantum communication, developing secure quantum networks that are nearly impossible to hack. Meanwhile, companies like Google and IBM are racing to build the most powerful quantum computers. Some people call this the quantum arms race, and whoever wins could have a massive technological and economic advantage. So what does this all mean for us? Well, quantum computing could revolutionize our world in ways we can't even imagine yet. And here are just a few of the possibilities. Medicine and drug discovery. Scientists will be able to simulate molecules and proteins at an atomic level, leading to faster cures for diseases. Climate science. Quantum computers could model and predict climate change patterns with extreme accuracy. AI and machine learning. AI could become exponentially more powerful, helping us solve problems faster and more efficiently. Finance and cryptography. While quantum computers could break today's encryption, they could also help build quantum secure encryption, a new way to keep data safe. We're still in the early days of this technology, but its impact will be massive. I'd like to present a mildly mind-bending thought. What if I told you that quantum computing isn't just changing the way we think about technology? It might also change the way we think about reality itself. There's a theory in quantum mechanics called the many worlds interpretation. It suggests that every time a quantum event happens, that's every time a particle could be in multiple states, our universe splits into different realities. Stay with me here. Think back to the flipping coin. Instead of landing either heads or tails, the universe splits in two, one where it lands heads and another where it lands tails. Now, apply that to everything, every decision, every possibility, every quantum interaction, and suddenly, you have an infinite number of parallel universes, each playing out a slightly different version of reality. Oh, reminds me of that movie Everything, Everywhere, All at Once. Some scientists call this the multiverse hypothesis. It's not proven, but it's a serious possibility that comes straight out of quantum mechanics. Physicists like Hugh Everett and even Michio Kaku have talked about how quantum theory might imply the existence of multiple, coexisting universes. So, could quantum computers, machines built to harness the power of quantum mechanics, one day allow us to detect or even interact with these other realities? We don't know yet, but the fact that quantum mechanics even suggests this possibility tells us one thing's for sure. Rick and Morty and Marvel Comics are definitely onto something. And that the universe is far stranger and more fascinating than we ever imagined. So where do we go from here? Right now, quantum computers aren't replacing your laptop or smartphone anytime soon. They're still experimental, expensive, and require extremely controlled environments. But just like regular computers went from room-sized machines in the 1950s to pocket-sized smartphones today, quantum computers will evolve. Physicist Michio Kaku believes that in the next few decades, we could have personal quantum computers, or at least cloud-based access to them. He states, quantum computers will change everything. They can break into every code of existence, from government's nuclear codes and financial systems, and solve problems in nature, with cures for cancer and heart disease. He goes on to say that by the year 2100, our destiny is to become like the gods we once worshipped and feared. But our tools will not be magic wands and potions, but the science of computers, nanotechnology, artificial intelligence, biotechnology, and most of all, the quantum theory. Egyptian entrepreneur and author Mo Gaddad has also spoken a great deal about how quantum AI could also help us solve some of humanity's biggest problems. He states, quantum computers can solve much more complex problems than classical computers can handle, like the problem of creating AI that matches or surpasses human intelligence. He goes on to say, the blinding speed when it comes to quantum computing, when it comes to artificial intelligence, might become a microsecond. Mo Gaddad wrote a book titled Scary Smart, which offers a deep dive into the rapid development of AI and the potential consequences of its integration into our lives, both positive and negative. I highly recommend the book, should you want to learn more. Scary Smart by Mo Gaddad. What's clear is that quantum computing is no longer just a theory. It's happening. And the more we understand it now, the more prepared we'll be for the future. So, should we fear quantum computing? The idea that a machine could crack the world's most secure codes, access financial systems, or even disrupt global security sounds like something out of a sci-fi thriller. But let's take a step back. Like any revolutionary technology, quantum computing is a tool, and tools can be used for good or harm. Yes, quantum computing could break current encryption methods, making personal data and national security vulnerable. That's a legitimate concern. But what's often left out of the conversation is that cybersecurity experts are already working on quantum-proof encryption, new security measures that will protect against these future threats. And then there's the other side of quantum computing, the potential for groundbreaking discoveries. Imagine new medicines developed in weeks instead of years, climate models so precise they help us prevent natural disasters, and AI that can solve humanity's biggest challenges. So, is this something we should fear? Maybe, maybe not. But it's definitely something we should prepare for and understand. Just like we navigated the rise of the internet, artificial intelligence, and nuclear technology, our responsibility isn't to stop progress, it's to guide it responsibly. If you think the future of quantum computing is just in the hands of scientists and world leaders, you would be incorrect. It's in the hands of all of us. Companies and governments are working on quantum encryption, the new way to secure data that's immune to hacking. But for it to be effective, businesses, policymakers, and even regular people like us need to push for the adoption of stronger, post-quantum security measures. Think about it. In the early days of the internet, people had to learn about cybersecurity, strong passwords, and digital privacy. The same will be true for quantum computing. As it develops, we need to stay informed, ask questions, and make sure it's being used responsibly for progress, not just profit or power. So whether it's through supporting ethical tech policies, voting for leaders who understand emerging technology, or simply staying educated, we all have a role in shaping the future of quantum computing. Quantum computing will change everything. But what that change looks like, that's still up to us. Because as Mo Gadot puts it, the true intelligence of the machines will be built by you and me. Thanks for tuning in to Curious Minds Infinite Answers. My hope is that today's episode gave you something to think about and maybe planted a seed to help further your desire to learn and grow on this important topic. If you learned something new, be sure to subscribe and share it with someone who might find it just as educational. Until next time, keep asking the big questions and never stop learning. Thank you for tuning in to Curious Minds Infinite Answers. I'm Courtney Christine Koskin, and I hope you'll join me for next week's episode as we proceed down the path of curiosity and discovery, uncovering various topics along the way. If you have any comments or want answers to your burning curiosities, drop me a line in the comments below. Until we meet again, find the good in the world, and if you can't find it, be the good.